What's up, everybody? How we doing tonight? Woo! Glad to see you all made it. Yeah, good deal, guys. Today's Tuesday. Today's the what's today? Today's the 8th. We're gonna be getting into the chapter 5 today. Chapter 5. What do we say? What is chapter 5? Woo! I gotta turn that down. Woo! All right. So what are we getting into today? Today, chapter 5. Analyzing Ethernet LAN switches. All right. So what I got going on today though is I also downloaded the updated version of GNS3, the 2.17, I believe. Yeah, it's the 2.17 version of their VM. I think it came out maybe about a week or so ago. I'm not too sure. But I was just going through all my software today because I want to give you guys like a comprehensive list, just like a comprehensive breakdown of what I got going on, you know, for the PC, for the virtualization hardware, and you know, and some of the software that I use as well. That way, if you guys have any, you know, questions or whatnot, you can always refer back to my my abouts page there up on Twitch. You guys can see a cool little breakdown on there. You know, this is so I was building the list. So I was building it today. Obviously it's not done yet, but this is kind of the beginnings. Oh wait, you guys can't see that. Let's go over to my desktop there. So yeah. So this was I was just building the little list for you guys right here. Off the operating system, which is like I've been talking to you guys about, it's Windows 10 Pro. This is the processor right here, the AMD Ryzen 5 1600 6-core processor, 3200 megahertz, 6 cores and 12 logical cores. I got the B50 Tomahawk motherboard, and I also got 48 gigs of physical RAM installed on that motherboard. This is the virtualization. I'm using it fully nested off of the host. All right. And again, that's the AMD. You can nest virtualization off that, and then Windows 10 Pro. Again, the Pro edition. That's what you needed. That's what you need to enable. Once you enable it in the BIOS, and then Windows 10 Pro allows it through the security functions. Okay. So what I'm using, again, this goes back to here. This is the layer 2. So this is it disappeared. All right, so this is VMware Workstation. All right, right here, and then I'm running. So this is the layer 2 virtualizer, and then this is where I run EXXI from. All right, no, that's VMware Workstation 16. All right, that's the Pro edition, and then I run EXXI from there. So this is EXXI again. That's the layer 1. So this is what you could run. So you can actually use EXXI as your operating system. So you can say if you had a server that, you know, had no operating system on it, EXXI is a layer 1, which is a bare metal image, and you would just be using EXXI as your operating system. And then today, like I said, I downloaded the updated version of GNS3. So this is the updated version of GNS3 right here. Again, all this stuff's running headless, so it's running headless. And then it's just, you know, it gives you the IP address that gets allocated by my DHCP server, and then right over here. So I've already added the Cisco IOSV image and the Cisco IOSV switch virtual image as well I just got done adding that to it just before the stream booted up. Yeah, I just got all this stuff put together real quick right before the stream happened, as I was trying to get dinner done and everything else with the kiddos. So I didn't get the chance to add any of the Docker images or whatnot. I don't have to worry about the VPS over here. I can do whatever we're gonna be doing today with the VPS image that it comes standardized with. So if you've had any experience with GNS3, obviously you know that unless you had the Cisco, unless you pay for the Cisco Modeling Lab subscription, which is a yearly subscription. It's about a $200 subscription every year, and again, it's worth its weight in gold. This is just these images right here is just what you got. So you got a basic, just some basic switches and whatnot. These two right here, these are acting as your exterior connections on GNS3 right there. And then, yeah, so that's all you're gonna get. And then you can go on the GNS3 website and you can download some Docker images and whatnot. I use the VM of GNS3. I don't use the local software. I found it as this. Sometimes it's just a pain in the butt. Sometimes because you would still need to run the VM with the local program to get GNS3. I mean, you don't have to, but to get like these Cisco images to run, you would have to have the VM. You have to have the VM able to actually connect to the actual local program, and then you can, then you'd be able to boot it up. But you'd be able to, use those simple switches and whatnot. I believe so, yeah. But I just use the VM image. It's an OVA file. It's and this is just the EXXI version of it. It's super lightweight. It's super neat too. And we're gonna use it. Yeah, I mean, I'm just booting it up right now, so I don't know if it's got any bugs or quirks or anything like that yet. But this is what we'll use today, maybe, depending on how well it works and whatnot. I haven't tailored. What do I got for? I'm giving it 1 CPU and 2 gigs. It should be all right. It should be all right. Just with that. Let's see. We'll just boot this up real quick. There, sure. Start it up. Start. There it goes. We'll just start that up real quick. It does. See how long it takes to start up too. We'll give it a little bit, and then let's just open a console to it. So the cool thing about this is I can actually open up a separate web console to it, because sometimes on Cisco Modeling Lab the little consoles get funky. Where'd the console go? Not ready for it. So I haven't. I haven't played with it all the way yet. It's not gonna console just yet. We'll give it a second. Go back to settings real quick. Just looking at the settings real quick, guys. Project. And shut it down. Come on. Those. Yeah. It up. All right. Getting through the quirks. That's it. You know it. What is it doing? Where is it sending this console to? Up, down. Well, there it goes. Alright. Huh. Okay. That's cool. So, there it is. It's just booting up right there. So, this is just the initial booting up of that switch right there. So, we'll let that do its thing for a couple minutes. And, yeah. Alright. So, that it just might take a little bit longer than on CML. Just because I'm not giving it as much, as many CPUs and as much RAM. I had to, like I said, I just booted up the OVF and it has just its own range of configuration that it automatically configures itself to. Later on, once I shut it down, I'll probably bump up the CPU usage and whatnot. Just it runs a little bit more fluid. Excuse me. It runs a little bit more fluid when you obviously when you give it a little bit more juice. There's the PC right there. PC, sorry, yeah. And this is right here. This is just a very, 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 very lightweight Linux operating system here. Yeah, it's free BSD there. And here, if you visit that website, free, wiki freecode.com.cn, it'll probably give you, it'll probably give us all the information that we need to know on it and whatnot. What's going on with the camera tonight? The screen on my camera keeps going in and out and in and out. All right, let's get our exam started. Remember, so last night we went over. Oh, we got some people in the. What's up, Beastie Bumble? How we doing? For which CCNA? You studying CCNA? Oh, so this is the CCNA 200-300 exam. I'm going through all. I'm starting from chapter 1 all the way because I got. So we're gonna be using. I got a subscription to O'Reilly Media, so we're gonna be going through the Pearson test prep. I own both physical hard copies of the book. And yeah, from chapter 1 all the way to what is it? Chapter, I believe, because there's 2 parts to the book. It goes all the way to. Because part 2 takes on all the way, so part 1's the biggest one. It goes away to building wireless LANs, and then chapter 2 starts at introduction to TCP transport application, and then it ends up around network automation. I took the CCNA CyberOps exam last year. Oh, did you, man? That's awesome, Bumble. Did you pass? I'm guessing you passed. Awesome, man. Awesome. No, dude, good for you. I started on my CCNA journey. Let me see. What was it? It was in August I started. And I started simply, I stumbled onto a David Bumble video. And from there, I was taken away by the awesomeness and just the amount of knowledge that goes behind learning this stuff, man. From just from obviously the CCNA starts at the very very fundamental, but then it progressively gets into configuring devices, managing devices, and then now it's then Wi-Fi, and then REST APIs, and then it ends around Ansible and Salt and stuff like that. I like how again they kind of consolidated all of the CCNA exams Cisco did to kind of give it a little bit more. I guess it makes a little bit more sense what they did with the CCNA exam now, because it gives you like it kind of gives you a nice broad touch, I feel as though, into what technologies are out there, what you're going to be doing, in your job and whatnot, because from here I'm going to be going after the new DevNet, the DevNet associate exam. That'll be, so once we get through this, the next one would be the DevNet associate exam. I'm already starting today. I had another I've already, again, because I use O'Reilly obviously, so I get to take advantage of a lot of the live courses, and last couple of days I've been in Xander von Wundt's Ansible class. It's the new, he just made a new course for the new Red Hat Enterprise Linux exam for their yeah exactly. Yeah, it is. It's great. It's great. And again, I really want to get on the I just want to know everything at this point. Bumble. But yeah, like I was saying, the last couple of days I've been taking Xander von Wundt's class, an Ansible class. It's been a deep dive into Ansible and whatnot. Ansible's fun. It can be a pain in the butt to get it all to work, but once you get it to work, it makes sense, and it makes sense why most companies these days are using Ansible as a management as their management software. A lot of doors open up, from there and whatnot. I'm really looking forward to just getting the full boat on all this stuff. Obviously, after the DevNet, I'm hoping to go into my CCNI, my CCNP. These questions are a bit stupid in the exam. The questions are they a bit stupid in the exam? They probably do a lot of questions probably to just to catch you. You know what I'm saying? At least that's what I've been hearing. Obviously, they can't really, nobody who takes it can talk to it because you got to sign the little NDA there. But whatever. This little the Pearson test prep. I don't know if you've ever used this, Bumble. But this stuff's great, man. We can load up, all kinds of stuff and go through there. My screen came back again. I don't know what it's doing. Yeah, it's good. Yeah, so if you've used it, man, you know it's definitely it's worth its weight. At least I found for myself, it's definitely helped me really retain and put the nails in my brain there to keep this stuff retained. But no, man, thank you for joining. Let me see if this is booted up. So Bumble, here's a question for you. Have you obviously you mentioned GNS3, so have you used Cisco Modern Lab and stuff like that? I really like Cisco Modern Lab. I think it's a great stuff. There it goes. Oh, that booted up kind of fast. Even with, I'm only giving it very, very minimum stuff right now. Oh, cool. Yeah, so we're gonna use GNS3 tonight, guys. To go over some of the basic commands. So tonight the this chapter covers the following exam topics: network fundamentals, exam the role of functions of network components, L2 and L3 switches. Okay, there is a difference. Yeah, yep. That and lab and two Bumble. I found just by, you know, it for me it's almost like the hands-on, getting in there and really labbing it up on, you know, various topics. I got this. This has helped me a lot too. I also got the advanced routing too, but the portable command guide book there. It pretty much takes this whole entire book and just breaks it down to specific labs and all the commands that go along with those labs and you know how to get it all. You know, it gives you pretty much the whole list of commands to get that lab up and running, or that particular configuration that you want to see work and whatnot. So, all right. Let's dive into it. Let's get this up and running, and we're gonna get started. Let me just grab. We got some coffee. You guys got your coffee ready? Get your coffee readies. I got my coffee readies. Well, let's get some coffee. Coffee time. My beautiful flowery mug I got here. It's good stuff. How does everybody take their coffee up there? Hope you all take it the way I take it. The only way to drink coffee. Black and hot. Alright. Let's go over to the whiteboard. Let's go over to the whiteboard, guys. Alright. We're at the whiteboard. Let's start diving in. You were right there. All right. Cool. All right. It's erased. All right. We got all the selected. We got chapter 5. Well, we got chapter 4. So, Bumble, if this is your first time joining the stream, what I've been doing is the chapter that we go over the day before, and in the last night's stream, we review it first thing on the beginning of the next stream. So, last night we reviewed chapter 4, which is it's pretty much the introduction to the command line using the command line interface. So, let's get started. All right. Your switch is in an air-conditioned locked wiring closet on the first floor of the building. There is a card reader on the door that allows only authorized personnel in the room. On Thursday, use Telnet to connect to the switch and issued the following command: hostname S1 N logout. I already know what happened. All right, so remember what I was going over on last night. So you're in the switch. All right, here's switch. All right. Yeah, so you'll be in global configuration mode here. So config. All right. You simply give it the host name. All right. You give it SW1, whatever, okay? And then you logged out, all right? Or end. You exit out of it, okay? Now, what did we forget to do? Now, what it's pretty much stating is the following Monday morning, you tell that into the switch and ran the show version, the show version command, and the following, you switch show version, yada yada yada. So let's scroll down so we can see. First, don't use Telnet. If you want everybody to see your passwords, you go right ahead, use Telnet. Everybody will know what you're doing. You got that right, Bumble. All right. So based on the output, what is the cause of the state of the hostname back to switch? So what didn't the engineer do? All right. The engineer did not do. Remember, we went over this pretty heavily last night. All right. They didn't do the copy. All right. Copy running config starter config. All right. So the engineer, they just said logged out. All right. Now we went over this. When you're inside of the switch and the switch is running, everything that you're, all your commands, everything that you're doing in that switch, all the configuration, that's a text file, okay? That's just being saved to RAM. All right? Now, your startup configuration, that is saved in NVRAM. All right? Non-volatile RAM. All right? And again, remember, these are text. They're pretty much just text files. And it's just all that configuration. By not running the copy, running config, start config, everything that engineer did was still in RAM. Yeah, cool. So if he ran the show run command, all right, he would get back his host name as S1. Cool. All right. If he had just simply ran the show start, all right, he would have saw though that his host name was still switched and it wasn't being saved as SW1. All right. So by running this command again, what it's doing is it's taking that text file from RAM and then saying, hey, I'm going to now deposit that in my NVRAM. Again, that's NVRAM is where your start config sits. Okay. So let's go down. Answer B is correct. So you forgot to save. You forgot to save. Yep, it is B. You know it. You know it. All right. If the engineer issued the copy running config starter config command, which Cisco memory type would the configuration been copied to? It would have been copied again to NVRAM. This is where it starts up on, guys. Okay, RAM is that's what's holding your running text configuration file. Your NVRAM holds your start configuration text file. Okay. All right. Which is the name of the Cisco iOS command line interface exec mode that allows a user to run more powerful commands? Okay. We have user mode. So in user mode, remember, you only had saying C and D. C and D. So what do we got? Configuration mode. Is that where we're at? So so you have user, boot. No. You have configuration mode. I'm pretty sure it is. Then you have enable mode. So we're going to select configuration. All right. Yeah. I'm just trying to think if it's going to be tricking me. There it goes. Okay. All right. When the Cisco iOS command line interface is initialized, accessed via console, telnet, SSH, with no extra privileges, which mode is the user placed in? So user mode. All right, using the cable to connect a Workbench PC to the console port on the switch. You notice that the switch is now responsive. A coworker mentioned that the same PC was used with the same switch earlier that day. The system LED on the switch is green. Consider the given scenario. What should the technician do? All right, we got to remember, select two answers. So verifies a straight through cable is being used. Nope. Verify a cable is being used is a crossover cable. Verify the correct physical connection has been made. Make sure the connection is a rollover cable. Check to see if the cable is a category 5 or higher. So we're going to go with rollover and see and make sure that we have an actual physical connection. All right. If an engineer has completed a series of changes to the Cisco switch and wants to ensure that the changes are saved and retained across the reboot, which command should be used? So we have the copy config, nope. Copy start, oh, that looks good. Then we have copy start, nope. Copy, nope. So remember, copy running config, start config, okay? All right. Refer to the diagram. Which of the following connections parameters are used when connecting to the console of the Cisco switch? All right. So we went over this yesterday. Remember, 9600, 8-in-1. 9600, 8-in-1. So that'll be using when you're using program like PuTTY or whatever terminal emulator that you're using. Most likely it's going to be PuTTY. All right. Oh wow, it only gave us 7 questions. That's it. All right. How'd we do? Woo! We went 1,000. Woo 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 woo. Good looking out, Bumbo. All right. So that was a good review, guys. I feel pretty confident that that we pretty much crushed chapter 4. So let's exit out of this now. We're all done with that. Let's get out of here. All right. Now, again, we're gonna dive into chapter 5 now. Okay, everybody? Clear my board real quick. All right. So, chapter 5, analyzing Ethernet LAN switching. All right. Network fundamentals. Explain the roles and functions of network components. L2, L3 switches. Describe switching components. MAC learning and aging. Frame switching, frame flooding, and MAC addressing. Okay. Let's just do the quick overview of the chapter. Describe the need of the basic operations of rapid PVSST spanning tree protocol. Identify basic operations. When you buy a Cisco Catalyst switch, Cisco Catalyst Ethernet switch, the switch is ready to work. So you can just dump, that switch on, on your LAN, on your local area network. Start plugging and playing on the thingies, and for them, as long as you're not getting too crazy, pretty much it'll start. You can start sending traffic right through there. You don't really need to get into it and, start messing with any of the configurations. That's just given that you have a pretty simple network configuration and whatnot. So, you got VLANs and everything like that, it ain't going to work, though. You got to start trunking. All right. So, yep. Part 2 of this book. Woo, stop scrolling so fast. You will learn how to build, configure, and verify the operations of Ethernet LANs. In Chapter 4, using the command line interface, you learned how to move around the command line interface. All right? Issue commands, configure the switch. This chapter takes a short but important step into the journey by explaining the logic a switch uses when forwarding Ethernet frames. Remember, a switch, its logic is layer 2. MAC addresses. Okay, remember that. Layer 2 MAC addresses. All right, it's not thinking about IP. All right, layer 3 switches, that's going to get into it different. You can pretty much turn a layer 3 switch into a router if you want. All right, but layer 2 switches, it's using, well, L2 switches. So L2, think L2, layer 2 MAC addresses, frames. Okay, L3 switches, L3. Remember, we're going to go up that ladder of the OSI model, of the TCP model, all right, to IP. Kind of thinking about that kind of logic, okay? All right. The second section of the iOS show command to verify the Cisco switches actually learned the MAC addressing, built the MAC address table, and then forward frames. All right. Thought I already deleted all these highlights I had done. Yes, I did not. Undo the highlight. Hey, it's actually unhighlighting it tonight, guys. I'm happy. Look at that. Woo! It's not giving me a super hard time. All right. So, which of the following statements describe part of the process of how a switch decides to forward a frame destined from a known unicast MAC address? Okay. Let's break out our handy dandy little thingy. Okay. We're going to say number 1. All right. So it compares the unicast destination address to the bridging or MAC address table. It compares the unicast source address to the bridging or MAC address table. It forwards the frame out of all interfaces in the same VLAN except for the incoming track of it. All right. It compares the destination IP. Remember, it has nothing to do with IP addressing, so we can already eliminate D. It compares the frame incoming interface to the source MAC entry in the MAC address table. Let's read that again. Compares the frame's incoming interface to the source MAC entry in the MAC address table. Okay. How does the switch decide forward a frame destined from a known? Okay, so it's already known. All right. It compares the address to the bridging. So now there's the frame. So remember, unicast is 1. All right, that's just giving us a clue right there already. So I'm gonna select. Let's go with what you got in there? A and B, mate. A or E? It's A. That's what I was kind of feeling that too. But I don't. I'm stuck on A or B, but whatever. This is the do I know, the question, the do I know this quiz already. So this is just a review. This is just seeing how much we already, we might know. So let's continue on. Let's not get too late, let's not spend too much time on there. Which of the following statements describes part of the process of how a LAN switch decides to forward the frame destined for a broadcast address, broadcast MAC address. So broadcast, multiple addresses, okay? Broad. All right. Which of the following statements describes part of the process of how a local LAN switch decides to forward a frame destined for a broad? All right. It compares the unicast destination address to the bridging MAC table. It compares the unicast source to the bridging table. It forwards. So it's going to be. It's going to be C. I'm going to say C. What do you think, Bumble? You think it's C2 as well? Yeah, I'm thinking it's C2, brother. All right. Which of the following statements best describes what a switch does with a frame destined for an unknown unicast address? Okay. So unknown unicast address. Forwards the frame out the interface in the same VLAN, except for the incoming. I think it might be A already, but it forwards the frame out the one interface identifying the match. It compares the destination. Nope. It compares the frame incoming to the match. So I'm gonna go with A on this one. Yeah, I think it's A2. I think it's A2. All right. Which of the following comparisons does a switch make when deciding whether a new MAC address should be added to its MAC address table? It compares the unicast destination address to the bridging or MAC address table. It compares the unicast address to the source. It compares the VLAN to the thing. Nothing again for IP. So comparisons the switch makes the deciding to source. I'm gonna say source. What do you think? Yep, that's what I'm thinking too. Okay. Stupid highlights. Let's get this highlight out of there. All right. A Cisco Catalyst switch has 2410-100 port numbered 0-1 through 0-24. The 10 PCs connect to the 10 lowest number ports, which those PCs working and sending data over the network. The other ports are not connected to any device. Which of the following answers facts displayed by the show? So, it's just so. Which of the following answers list facts displayed by the show interface on the status command? All right, so it's just showing me right here. So it's just showing the VLANs. Yep, cool, and it's on these things. Okay. Port 0-1. Nope, they're all gigabit. Consider the following. Oh, I'm getting stumped over here on this one. Huh. C. Yeah. Yeah, it'd be C. That's true too. But I'm thinking it's C. Let's go with C. So say 5 is C. Thinking. All right. So here's our little image. Which of the following answers is true about the switch? Which is true about the switch? The output proves that gigabit 0-1 is connected directly to B. Yep. The switch learned the 3 MAC address when the switch was powered on. The 3 listed MAC addresses are learned based on the destination address. Nope. C was learned from the MAC address source on frame gigabit 0-3. So we have the all C's, the all B's, and all A's. This output proves that port gigabit connected directly to. Which one is true? Alright, let's go with D on that one. Alright, let's see how well we did. Let's get our little handy dandy marker out. Alright, I would do A. Woo! C, 2, woo! 3, A, woo! B, woo! 5, C, woo! And 6 is D. Woo! Woo! No, thank you, man. I appreciate the help, Bumble. All right. So we have a little bit of an understanding on the concept of Ethernet LAN switches. All right, so we're gonna go through the chapter now. We're gonna get through some of the just the kind of sticky topics that we got, just to nail. So, what I've kind of learned, if I have to guess on one of these questions, I might, that means I really got to get back into it and just make sure that I'm not guessing on the answer, that I actually confident myself that I know the answer. Even though, we got them all right, but we want to know that we got them all right. So, all right, let's move on. All right, LAN switching concepts. A modern Ethernet LAN connects users, devices, as well as servers into some switches, with switches then connected to other switches. Sometimes the design. So this right here, this is illustrating like the like a campus design or whatnot. Okay. All right, and it's gonna go. I believe this chapter touches on STP and RSTP, and why it's so important because of this type of design. If I don't want to get into all that right now, but I'll just touch on it. Pretty much, you will blow up these switches if STP and RSTP wasn't working on this. Okay, all right. So part of the LAN called the campus LAN supports the end user population as shown on the left, and end user devices connected to the LAN, which in turn connects to other switches. Yep. The path of the rest, the campus LAN switches sit in the wiring closet, so it's pretty much stating that here's in wiring closet. I'm saying you could probably have all these switches just sitting in one wiring closet in one building, and then this is just doing the same thing. And then you got your little server farm over here. Here's Bob's server. Here's some websites. Here's some applications that are running. All right, let's keep it moving. All right, on the right, yep. Got our servers, data centers. Cool. Yep. All right. So campus LAN and data center LAN, conceptual drawing. To forward traffic from a user device to the server and back, each switch performs the same kind of logic independently from each other. The first half of this chapter explains the logic, how a switch chooses to forward. Here's the key word, Ethernet frames. All right. MAC addresses, Ethernet frames, all right? Do you work in the IT right now? No, actually, I'm a heavy equipment operator, and back this February, I ended up blowing up my back, and since I've been pretty much down and out for a while, it wasn't too long ago that I started being able to walk and stuff like that again, and be able to get back to doing things again. But my whole time I was off my feet, again, that's when I say I stumbled upon David Bumble. Then, from there I just took the deep dive into this. I've never worked in IT, so what I try to tell people is I'm not trying to be the subject matter expert. I am learning this as we're learning this together. Okay, so that's why I'm getting, when I go over this, I want to go over it exactly from the source. That way you're getting the same information that I'm getting at the same time, guys. All right? All right, let's move on. I'm hoping to get a job in IT. That's what my goal is right now, Bumble. All right. Overview of switching logic. Ultimately, the role of the LAN switch is to forward Ethernet frames. LAN, local area networks exist as a set of user devices. That's drop my marker. Come here, marker. So that's, PCs, laptops, cell phones. Those are end user. So when you hear the terminology end user devices, all right, that's what it's relating. That's what at least. My black marker go. I dropped that too. Whatever. Go with red. So end user devices, pretty much the end of the conceptual end of the network is going to be it's sending a service to that to that device there, okay? And then obviously you're then going to be sending traffic back to his, again, here's the little server farm and whatnot. All right, let's keep it moving. Thank you, Bumble. I appreciate that, man. Appreciate the love, baby. The love. Where'd my marker go? Oh, there it is. All right. All right. So here's a key topic right here. Well, here's one sentence I want to review. LAN switches receive Ethernet frames and then make a switching decision, either forwarding the frame out some other port or to ignore the frame. To accomplish this primary mission, switches perform 3 actions. And here's our key topic. Deciding when to forward a frame or when to filter, not to forward a frame based on the destination MAC address. Okay? Preparing to forward frames by learning MAC addresses by examining the source MAC address of each frame receiving by the switch. Preparing to forward only one copy of the frame to the destination by creating a layer 2 loop-free environment, which other switches by using here's that big one again. My most favorite thing, STP, spanning tree protocol. All right. Without spanning tree protocol, you will by hooking up switches to other switches, okay? What you will create is called a broadcast storm, okay? So here's switch 1, here's switch 2, and here's switch 3. So switch 1, switch 2, switch 3. All right, so I'm just going to simply make a connection from here to here, okay? Make a connection from here to here. Then I'll make another connection from here to here, all right? What I've done is I've created, in conceptually, is a circle, right? A loop, all right? If I send a frame, all right, out switch 1's port, it's gonna go right into switch 3, right out switch 3, into switch 2, out of switch 2, into switch 1, back out switch 1, into switch 3. And again, this is if these switches are not using STP or RSTP. What this will do is it'll send an infinite loop, a broadcast storm, out these switches. Okay, all right. I've created this. Yeah, in the premise company, and since 1 year I've been working as a pen tester. Oh, have you? So I what was it? About a month or so, I took Omar Santos's one of Omar Santos's class. It was high level Bumble. It wasn't low level type stuff. It was high level, just an overview of pen testing, red team, and stuff like that. Omar Santos, if you've never heard of him, super. He just actually dropped, I believe, a brand new book published by Cisco on network security and stuff like that, going into a lot of that stuff. I haven't really messed with pen testing too much. What I will be doing, I have been progressing in my Linux knowledge. I primarily use, an Ubuntu image. I, mess around with it. Again, that goes back to Ansible and whatnot. Actually, today I downloaded, some of the updated versions of Fedora and CentOS. There's not a newer version of Ubuntu 20.04 yet. But I did grab up Fedora 33 today, and then CentOS 8.4.2011, I believe, is the new update to CentOS. What I'll do is every once in a while I'll jump over here and I'll boot up a couple Linux VMs real quick, and I'll mess around and whatnot. But I really haven't jumped into too much pen testing yet. All right. All right, the first action is the switch primary. The first action is the switch primary job. All right, so deciding when to forward a frame or when not to forward a frame based on the destination MAC address. Okay, so that is the first action that's the primary job of a switch. All right. Note throughout this book, discussion of LAN switches, the term switch port and switch interface are synonymous. So when you're gonna see the terminology switch port or switch interface, it's talking about the same thing. So when you see gigabit 0-1 whatever, or fast Ethernet 0-4 whatever, you're gonna see switch port, all right, or switch interface. All right, don't get hung up on the terminology. Switch port, switch interface, think the same thing. All right. I recommend build an Active Directory lab and get hands-on. Every company has. Yep. Okay. I will help you to get a foothold on Active Directory and Azure. Active Directories are everywhere. Thank you, man. Appreciate that, bump. Definitely. Whisper. Twitch whisper to me or something like that after this or something like that. Ever since I jumped into obviously all this, Linux is the future, and Linux is the future to everything from Microsoft to AWS to Google to Rackspace. All those servers are running. For the most part, it's all Red Hat Enterprise Linux. Google, I believe, runs some Ubuntu. Microsoft Azure. Even they're making the transition. I wholeheartedly they're making a hard transition over to Linux. You got the Windows, what is that? The Windows subversion of Ubuntu now that you can just download off their the Microsoft Store, and you can actually fire an Ubuntu up without dual booting your PC, and you can use Ubuntu and PowerShell, almost as the same thing. It's pretty neat. Okay. Yep. All right. Let's keep it moving. Although chapter 2 sections titled Ethernet Data Link Protocols already discussed the frame format. This discussion of Ethernet switching is pretty important. So reviewing the Ethernet frame at this point might be helpful. Figure 5.2, all right, shows one popular format of the Ethernet frame. Basically, a switch would take a frame shown in the figure, make a decision on whether to forward the frame and send the frame out the interface. Okay, so it's looking right here. All right, in that part. All right. Most of the upcoming discussion in figures about Ethernet switching focus on the use of destination and source MAC address fields in the header. Okay, header. All right. All Ethernet frames have both a destination and source MAC address. Remember we went over this, how when you're forwarding frames to through a router and whatnot, it's removing those source MAC addresses and adding, it's de-encapsulating and re-encapsulating those packets in those frames and whatnot. Okay. All Ethernet frames, both the destination and source, both are 6 bytes long, represented by the 12 hex digit in the book. All right, and are key part of switching logic discussed in this section. Okay. All right. The companion website. Yep. We don't need that. All right. Forwarding a known unicast frame. So when we think un, that's single. All right. To decide whether to forward a frame, a switch uses dynamically built tables that list MAC addresses and outgoing interfaces. Switch compares the frame destination MAC to the table to decide whether the switch should forward a frame or simply ignore it. For example, consider this the simple network shown in 5.3. Fred sending the frame to Barry. So Fred sending it over to Barry. There we go. Barney. So destination 2.2.2.2.2. All right. The frame came in to F01. All right. Destination. All right. Is Barry 2.2.2.2. Forward it out F02. Don't send. So it's making. This is where it's using its logic. Don't send out of F03 in F04. So fast Ethernet 0-3 and fast Ethernet 0-4. Don't sending out those ports, all right? Because it's using its MAC address. It's established MAC address table. Here's its established MAC address table. And you'll note it's holding its MAC addresses for Fred, the 2s, which is Barney, the all 3s, which is Wilma, and then the all 4s, which is little Miss Betsy over here. All right, and then it's, you know, in that, this is where it's using it. Okay, well, at least this is where its logic comes in, and that's the reason for it building those MAC address tables. Okay, all right. Sample switch forwarding in the figure. Fred sends the destination 2.2.2. Yep. Okay. Let's read the note real quick. A switch MAC address table is also called a switching table or bridging table. So there's some terminology right there for us to remember. Okay, switching table, bridging table, also can refer back to the MAC address table. Okay. So let's keep it moving. All right. Key. Let's go over to the key topic. A switch's MAC address table lists the locations of each MAC, each MAC relative to that switch. In local area networks with multiple switches, each switch makes an independent forwarding decision. Say that again. In a LAN with multiple switches, each switch makes an independent. All right. This switch is going to make his own decisions, and this switch is going to make his own decisions, okay? On its own MAC address table, okay? Together they forward frames so that eventually it arrives at the destination, all right? First, for the example in 5.4 shows the first switching decision in case Fred sends a frame to Wilma, destination all 3s. The topology has changed versus the previous. This time it has 2. Fred and Wilma connect to switch. Fred and Wilma, what is it saying? Yeah, 2 different switches, exactly. And this is the logic of where it's going. So, frame enters fast Ethernet 0-3 to destination all 3s. Okay, MAC address table entry list forward out gigabit 0-1. So, here's the MAC address table for switch 1. All right. And what you can notice is that Wilma's MAC address and then Betty's, the all 4s and all 3s, all right, what it is stating is on switches 1, gigabit 0-1. So it's going to say, if I see these destinations, all right, I'm going to send it out this one port because I know that this one port should have these MAC addresses out there, all right, and then it sends it over to switch 2. Switch 2 gets those frames, all right, and then it has its own MAC address, stating again, Betty and Wilma are located. Now it's saying Betty and Wilma are located out of these 2 ports, okay. But again, if it was the traffic were to go in the other direction to Fred and Barney over here to the all 1s and all 2s, it again would state that it just sends it out that one port, okay. That's switching logic. Very basic, very easy thing to conceive conceptually. Okay. All right. Forward decision with 2 switches. Yep. The same frame next arrives at switch 2, entering switch 1 to gigabit 0- interface. Also shown, switch 1 uses the same logic. By using switch 2's table, the MAC address table lists the forwarding instructions. For the switch only. In this case, switch 2 forwards the frame out F03 based on switch 2's MAC address table. Again, it's just going over exactly what we just covered. Okay. All right. Forwarding decisions with 2 switches and a second switch. All right, let's just read the note. The forwarding choice by a switch was formerly called a forward burst filter. Forward burst filter decision because of the switch also chooses not to forward to filter frames, not sending the frames out some port. So it's pretty much stating that it's just going over the logic of, all right, these MAC addresses are assigned to this port. So if I get a MAC address within this range, that it matches this on my table, I'm not going to send it out some other port just because I can't. Okay. All right. Hey, Bumble man, good looking out. I'll see you tomorrow. I'll be here at 5 o'clock, 5 p.m. Eastern Standard Time tomorrow. Tomorrow we'll be reviewing Chapter 6. Have a good night. All right, learning MAC addresses. All right. Thankfully, the network staff does not have to type in all the MAC, all those MAC address table entries. Instead, each switch does its second main function. All right, second main function to learn the MAC addresses and interfaces to put it into an address table. Okay, so it's learning it. Okay, with a complete MAC address table, the switch can make accurate forwarding decisions or filtering decisions, just as discussed. Okay, all right. Switch builds the address table by listening to incoming frames. Let's say that again. It builds the address table by listening to incoming frames and examines the source MAC address in the frame, not the destination, the source. So it wants to know, okay, I just got this frame from Fred, all right, out of my, from, not out of, but from my F0-1 interface. I'm gonna now remember that my F01 interface is Fred's all ones MAC address, okay? Not the destination, but the actual source, okay? All right. Let's move down. Figure 5.6 depicts the same single switch topology network 5D, but before the switch has built any addresses tables, the figure shows the first 2 frames sent in the network. First frame from Fred, address to Barney, and Barney then responds address to Fred. So it's just going over its logic. Here's my table. My table is currently empty. All right. Here's switch 1's empty MAC address table, and then all of a sudden, Mr. Fred from the all ones MAC address out of my F01 port. I just got a frame from there. Okay, let me punch that into my MAC address table. All right. Now, it doesn't say, okay, here's my, it doesn't say here, it doesn't say the destination. Grab some more coffee. I got tea and coffee going at the same time. I'm going to be up all night. All right, so again, it's building its addressing table from the source. Let's just nail that in, okay? Not the destination. All right. Yeah. So here in this figure right here, figure 5.6 depicts the MAC address learning process and ignores the forwarding process and therefore ignores the destination MAC address. Okay, there it goes. Ignores the destination MAC address. Okay. Focus on the learning process and how the MAC address grows at each step, as shown on the right of the figure. The MAC address, the table's empty. All right, shown on the upper right. Yep. Again, what we just went over. When Fred sends that frame, it's just gonna say, okay, there's Fred, and then when Barney sends that frame back to Fred, now it learns Barney's. Okay, it's not gonna learn Barney's by getting Fred's. Okay. All right. Let's move on. Forwarding unknown unicast broadcast frames. Forwarding unknown unicast 1 broadcast multiple, all right, that LAN, that VLAN, okay, all right, frames. Now again, turn your attentions to the forwarding process. Using the topology 5.5, what do you suppose the switch does with Fred's first frame? The one that occurred when there were no entries in the table. It turns out when there is no matching entry in the table, switch forwards the frames out all interfaces. So in this, all right, in this topology, that was the same up here, all right? When Fred sent that frame to the switch, and the switch had no MAC address table, all right, it's going to send that frame that was going to Barry out all its interfaces, all right? All its interfaces. It's going to say, okay, well, I don't know the all twos just yet, so I'm going to send it out my F04, my F03, and then my F02, just so I can then see, because I don't know where this actual MAC address, the destination, I don't know where that destination MAC address resides. All right, I don't know which out port, so I'm going to flood it. Okay, all right. Switch flood. The switches flood unknown unicast frames. Flooding means that the switch forwards a copy of that frame out all ports, except the port on which the frame was received. The idea is simple. If you do not know where to send it everywhere. Okay, so remember that. When a switch receives an unknown unicast frame, it sends it out all its ports, all right, or interfaces besides the interface on which that frame came from. Okay. All right. Switches also flood local area network broadcast frames destined to the Ethernet broadcast address FFFFFFFF. So when you see this type of addressing, that's a broadcast address. Pretty much, it's going to go everywhere. That frame's going to just go through your wire. Okay. Based on this process, because this process helps deliver a copy of the frame to all devices in your local area network. Okay. Yep, we kind of covered that already. All right, avoiding loops in STP, spanning tree protocol. Very important, super important. Like I said, I made a lab in CML, and I probably shouldn't have done this, but I made a lab in CML, which is again Cisco Modern Lab. That's the emulating virtualized software that you've seen me use in the last couple of streams. Okay, now that's using real network images, and it's also relying heavily on the CPUs that I'm giving ESXi over here to run it. All right. So here's, all right, I'm giving this actual six CPUs. Okay. What I did when I hooked up, I did the same thing I did on that previous picture here. All right. I took 3 layer 2 switches. All right. I took 3 layer 2 switches. All right. And I made those simple connections. All right. The second I hooked up this interface right here on the switch. Now again, it can just be whatever. Switch 1, switch 2, switch 3. Okay. Now the switches I was using were just super basic layer 2 switches that had they were unmanaged, unmanned switches, which pretty much is, there was no way for me to log into these switches and do anything. There was no actual console to these switches. Okay, they're dumb switches, whatever. Mainly even though they're switches, they're more like hubs. Okay, they're just using to be able to take that frame and put it through multiple ports from there. Okay. The second I hooked this up, span and tree took off. I mean, it started. My CPUs, on Cisco Modern Lab, you can see on my bottom of my screen my CPU usage. Now it runs around 15% when I'm using multiple devices. It went from 15 to 100% CPU usage, and my computer started humming like I've never heard it hum before. And right there, I had to disconnect. I had to remove that link right there, or obviously I would have, I could have possibly actually damaged my physical computer. And that's why spanning tree protocol, and what this is going to touch on, is a very important part of switches, Ethernet switches. Okay, all right. Now you're going to hear, as we progress in these chapters, you're going to hear RSTP. All right, which RSTP is a newer version of just STP. All right. There's a lot of similarities, almost the same. But there's also some identifying differences that we're going to have to learn as we progress here, okay? All right, move on. All right. Now what's to avoid loops by using spanning tree protocol. The third primary feature of a LAN switches is loop prevention. As implementing by spanning tree protocol, without spanning tree protocol, any flooded frame would loop for an indefinite period of time in an Ethernet network with physical redundant links. So that's by connecting all three. We're using redundant links, all right? And there's a reason why we do that. If the reason why we want redundancy, if something were to fail, at least we know that traffic would possibly still be able to get to where it needs to go. So it's very important inside of a network that you create redundancy, okay? And this is to prevent what happens when you create redundancy, okay? All right, the result of STP is good, all right? Frames do not loop indefinitely, which makes LANs usable. However, STP has a negative feature as well, including the fact that it takes some work to balance traffic across redundant alternate links. A simple example of the need for STP is obvious. Remember, the switch floods unknown unicast frames and broadcast frames. Shows figure 858 shows an unknown unicast frame sent by Larry to Bob, which then loops forever in the network because the network has a redundancy. So all three of these switches connected. All right. Bob sent Larry, here's my frame, and then Bob's over here. Bob didn't get that frame, and then, ooh boy, we're lighting this up. All right. Note that the figure shows one direction of the frame only, just to reduce clutter. But a copy of the frame would also loop the other direction. So it's gonna go this way, and it's gonna go that way. It's gonna be a madhouse of traffic just going right through that network. Okay. All right. Network with redundant links without STP, the frame loops forever. Yep. Cool. All right. The flood of this frame would result in a frame rotating around the three switches. So each switch floods that frame. Yep. And while the flooding process is a good mechanism for flooding unknown unicast and broadcast addresses, the continuing flooding of the traffic in the figure can completely congest a LAN to the point of it being unusable. So once that broadcast storm is going, your network is gonna it's gonna die pretty much from there. If you don't take care of it, you don't stop it, you don't prevent it, whatever. But by default, most Cisco switches, Catalyst switches, have STP, but by default already enabled inside of its BIOS. Well, inside of its iOS programming. Okay. All right. A topology 5.8, but the redundant links is good, but we need to prevent a bad effect of those looping frames. To avoid the looping frames, all the switch needs is STP. STP causes each interface on the switch to settle it into either a blocking state. There we go. There's some key things to remember. Or forwarding state. All right, blocking and forwarded. We'll go back to my handy dandy my little depiction here. Switch 1, switch 2, switch 3, whatever. Make that 2, make that. Okay. So when you have all the redundancies hooked up with STP and RSTP, all right, what it's going to call, and again, this is going to get into later chapters, but it's going to be using, it's going to be looking for a root, all right, root bridge. Is that what it's called? Root bridge, root switch, whatever you want to call it, all right, and it's going to be using the MAC address. It's going to be looking for the lowest denominator, pretty much the lowest MAC address, and we're just going to say, for instance, that this switch right here, this will be switch 1 now, this will be switch 2 now, this will be switch 3 now. Switch 1 became root, all right. Now on root, the ports that are on root, what it's going to happen is on switch 2, that this port on switch 2 now, because it has, again, this is going to get into the cost of moving frames through this network here. So we're just going to say, for instance, that the cost to get from L2 to L1 is 4. The cost to get from 3 to L1 is 4. But the cost to get from 3 to 2 to 1 is 8. Same thing here, from 2 to 3 to 1 is 8. Okay, so then this will become the root port. This will become the root port. All right. And what it's going to then do, it's going to put these ports right here. All right, these ports. Let me get my red marker out. Queen, don't want queen. We want win. Win. All right. It's going to put these ports on switch 2. It's going to block that now. Same thing on switch 3. It's going to block that now. All right. By blocking those, it's not shutting it. It's blocking them. Okay. By blocking those ports, what's going to happen now is that frame is not going to be able to perform a continuous loop within that network. Okay, guys, that's just like a simple high view of STP. All right, well, we're going to dive into that as, again, these chapters progress and our knowledge increases. Cool. Coffee time! Get your coffee. Got my coffee here. All right. Woo! I'm gonna be up all night long now. I'm fired up, ready to go. Send me in, Sergeant. Send me in. All right. Squeaky, squeaky, squeaky. All right. All right, let's continue on. All right. Yep. STP behaves identically for a transparent bridge in a switch. Therefore, the term bridge and switch and bridging devices all are used interchangeable when discussing STP. So bridge. So switches you can think as bridge. And that's all it's pretty much saying. So if you hear the terminology bridge, think switch as well. Okay, same kind of logic, same kind of principles go into the two concepts. Okay, chapter 9 of this book. So once we get to chapter 9, we're going to be looking at Spanish tree protocol concepts, examining STP into depth, including STP to prevent loops. Okay. All right. So LAN switching summary. Switches use layer 2 logic. Remember, layer 2 MAC addresses, frames. Okay. Layer 2 logic examining the Ethernet data header to choose how to process frames. In particular, switches make decisions to forward and filter frames, learn MAC addresses, and use STP to avoid loops. All right. Switch forwards the frame based on the destination MAC address. Okay. If the destination MAC address is a broadcast, unicast, or unknown destination, the switch forwards the frame. So again, if the destination MAC address is an unknown MAC address, doesn't care if it's a broadcast, doesn't care if it's a multicast, and it doesn't care if it's a unicast. So one thing to remember, if it's an unknown unicast address, that frame, no matter what, is still going to be flooded all other interfaces on that switch. Okay? Let's keep it going. If the outgoing interface lists the MAC address in the list in the MAC address table is different from the interface in which the frame was received, the switch forwards the frame out the outgoing interface. Okay, if the outgoing interface is the same as the interface in which the frame resides, the switch filters the frame, meaning that the switch simply ignores the frame and does not forward it. Okay, all right. Switches use the following logic to learn MAC address table entries. For each received frame, examine the source MAC address and note the interface from which the frame was received. If it's not already in the table, add the MAC address. Learn. Yep. Switch uses STB to prevent loops from causing the interface to go down. It uses STB to make sure you don't blow up your network. Okay. All right. Verifying and analyzing Ethernet switching. A Cisco Catalyst switch comes from the factory ready to switch frames. All you have to do is connect it, power the plug, plug in the Ethernet, and then the switch starts forwarding incoming frames. All right. Connect multiple switches together, and they're ready to forward frames between the switches as well. All that, and the big reason behind this default behavior has to do with default settings on the switch. All right. Let's review the default settings. All right. The interface are enabled by default, ready to start working once the cables are connected. All interfaces are assigned to VLAN 1. All right. So by default, all Cisco Catalytic switches, their native VLAN is native VLAN 1. All right. Now, in your network, you may want to change that just because by everybody knowing that my native VLAN is 1, somebody could potentially, perform some kind of possible malicious act. Okay, so it's just stating that the native VLAN in all Cisco Catalyst switches is VLAN 1. All right. 10.100 and 10.100 SE interfaces with algorithms by default. Okay. The MAC learning forward frames logic all works by default. STP is enabled. So again, there's that terminology, and there's that saying. STP is enabled by default on Cisco Catalyst switches. All right. Demonstrating MAC address learning. Show MAC address. There's a good command to switch to see the MAC address table. Is show MAC address command with no other command parameters. This command lists all known MAC addresses in the MAC address table, including overhead and static MAC addresses. All right. To see that dynamically learned MAC address table only is listed in the show MAC address dynamic command. So you have two different commands. So you have show MAC table, so show MAC address table, then you have show MAC table dynamic. Okay. So what it's stating is dynamic will show you only the MAC addresses that were pretty much learned dynamically. All right, they weren't statically put there. All right. In this example, the chapter uses almost no configurations. This example in the chapter uses almost no configurations. Also, if you just unbox the switch when you first purchase it, for example, the switch has no configurations on it other than hostname. To set the meaningful hostname, all right, so it's just going over the erase, the delete, reload, and then hostname 1. Shows a MAC address table. All right, we're gonna get into that. First focus on the two columns on the table, the MAC address and the port address column on the table. They should show primarily the match, the earliest single. All right, so it's just stating some facts here. So you have the all ones at F01, the all twos at F02, the all threes at F03, the all fours at 4. All right, the total MAC address learning is 4. Continue on here. All right, switch interface. The first example assumes that you've installed the switch and the cabling correctly, and the switch interface are working. Once you do the initial incorrect, all right, once you do the installation and connect to the console, you can easily check the status of those interfaces by the show interface command. All right, cool. And it's just showing us all 1 billion, all 1 billion. All right, that's all the interfaces that are on that switch. Now, remember, we're in CNL2. By default, it only gives you 4 interfaces, and the reason why behind that is it takes less time to load up. All right, but naturally on your switch that you might have used at your company or whatnot, you're gonna see a whole laundry list like this. Okay. Whoa, I don't want a whiteboard, you crazy guy. Right. Sorry about that. All right. Focus on the port column for a moment as a reminder. Cisco Catalyst Switch named their ports based on faster specification support. So in the S4, in the switch has 24 interfaces. Yeah, cool. All right. Yeah, so it's just going over that. All right. Note, you can see the status of a single interface. For instance, interface in a fast Ethernet 0-1 status. All right. That's if, again, you're troubleshooting and you just want to go back and then figure out what's going on with a particular interface. Now, you don't want the whole laundry list. Say you got, whatever, 24 ports. You don't want to see all 24. You would just do the show interface, whatever port you want to look at. Okay. All right. Yep. All right. Finding entries in the MAC address. All right. With a single switch and only 4 hosts connected, you can just read the details of the MAC address table and find information you want to see. However, in a real network with lots of interconnected hosts and switches, just reading the output of the MAC address, you can see how hard this might be with hundreds of entries. So it's just, where'd it go? Oh, it's not showing that. All right. Thankfully, Cisco's iOS supplies very similar, several more options of the show MAC address command. All right, so it's just getting into that. It's telling you how to, divvy up the MAC addresses here. All right. Yep, same thing. Just going over that again. All right. Finally, you may also want to find the MAC address table entry for one VLAN, which you guessed is in. You can add the VLAN parameter. Cool. So that's just going to get into VLANs and whatnot. Well, it's not getting into depth about VLANs. It's simply just stating that you're gonna, you'll see if you have a certain interface or certain port assigned to a particular VLAN. Okay. All right. Here we go. MAC address timing age. All right. This goes to prevent what I believe it's called man in the middle type of attacks, where a malicious host would just start spamming frames in your network with different MAC addresses and whatnot. And you'll actually fill up your whole entire table, and you won't then be able to forward traffic throughout that switch there. All right. And again, that goes back to why you want to take VLAN 1 and maybe change it, alter it, and whatnot. So, all right. Each switch also removes the oldest table entry, even if they are younger than the age time setting in the table. All right. The MAC address table uses connect addressability memory. Let's write that down. Connect addressable memory. CAM. Let me write that down. That's a good one to remember. So we got CAM. All right. That stands for thingy over here. All right. Content addressable memory. All right, CAM. Content addressable memory. All right. These are one of our key topics to remember. All right, a physical memory that has a great table to look up the capacities. However, the size of the table depends on the size of the CAM. All right. In particular, modules of switch and based on some configurations, settings of the switch, with a switch, when a switch tries to add a new MAC table entry, in the fields that are that full, switch times out and the oldest table entry to make space. Okay. For perspective, yada yada yada, has 8,000 entries. Some that exist in Cool. So here we go. This is just giving us some show commands to do. All right, show commands. So if you guys are jotting this down, so here's our show commands. So clear MAC address table, dynamic LAN, clear MAC address table, dynamic interface, clear MAC address table, dynamic address. Okay. All right, MAC address tables and multiple switches. Finally, to complete the discussion, it helps to think about an example where with multiple switches, just to emphasize how MAC address learning. All right, forwarding, flooding happens independently of each switch. Consider the top topology and pay close attention to the port numbers. The ports were purposely chosen so that neither switches used any of the same port. Okay, so it's just pretty much saying that when they hooked this up, they made sure they didn't hook it up to the same port names. Okay, cool. All right, troubleshooting two switch topologies. Think about a case in which both switches learn all MAC addresses. For instance, that would happen if the host on the left communicated with a host on the right. Switch 1 shows the MAC address table from the MAC. Ooh, I gotta drink some more coffee or something. Hold on, guys. Woo! I'm all fired up. All right. Let's get it. All right. Yep, switch 1's own port number, because switch 1 uses that information to decide where switch 1 should forward the frame. Switch 2, MAC address table, this switch 2's. Yep, cool. So this is similar to how we were talking about how when the frame comes in, the MAC address table gets updated with the source MAC address, not the destination, okay? And it says it's out this port, okay? And it floods out that frame off to everybody else, all right? Then when it reaches, Betty Sue over here on the right, Betty Sue obviously then sends a message back with her as her MAC address as the source now. Now, what's up, Detox? Oh man, I haven't learned anything about pen testing yet, man. I've been still diving into CCNA. How you doing, man? Good to see you, brother. Thank you for coming in. All right. So right now we're talking about MAC address tables and layer 2 Cisco Catalyst switches. Okay. So again, when that frame gets sent out by Betty Sue, again that table, that MAC address table and that switch gets updated again with Betty Sue's address, and then it now knows where Fred is because it already got Fred's frame. Okay. And again, if everything was hooked up to do 2 different switches, all right, this is the kind of what you would see. Okay, under the show MAC address command. Okay. All right, chapter review. All right, we got some key topics. The three main functions of a LAN switch. All right, process to forward a known unicast frame. Process to forward a known. So we have process to forward a known unicast frame. Process to forward an unknown unicast frame. Now remember, unknown doesn't matter if it's unicast, broadcast. It's going to flood that frame throughout that layer 2 network. Okay, but if it's a known, it's going to just push it out to that interface, to that port. Okay. Process of how the MAC address learns. Summary of switch forward and logic. The show MAC address table dynamic. Okay. Do labs again here. Do the labs, guys. Download Cisco Packet Tracer. Okay. All right. Key terms you should know. Broadcast frame. Known unicast frame. Spanning tree protocol, STP. Unknown unicast frame. MAC address table. Forward and flood. All right. And then here is some command line interface commands. All right. So we have some show commands. Show MAC address table. Show MAC dynamic. Show dynamic VLAN. All right. Show dynamic address MAC. This is so you can narrow down your searches on how you want to find the information that you're looking for. Okay. All right. There's some more show commands right there, guys, and then it has obviously the clear at the very end. All right. Let's go over to GNS3. What I will do, let's grab another switch here. All right. Let's get those. Those are, as you can tell, we got green over here, so those are just firing up right now. That the second switch that we added to the topology, that's just gonna boot up real quick. I'm gonna move over to my desktop now. You there, and move you right here. All right. Alrighty, everybody. Move down over here now. Hello. Let me move my view to my desktop. Hello again, everybody. Good to see you all. Thank you all for coming again. All right. Let's continue on. Let's get back to work here. Okay. All right. All right. Let's make some more connections here. And it, so there is a lot there is a lot I like about GNS3, all right, in comparison to Cisco Model Lab. Now, I'm not going to take anything away from Cisco Model Lab. I think Cisco Model Lab is an extremely great VM software, whatever you want to call it. But the team over at GNS3, they've put together a extremely awesome program here. And what I really like is you see how it's just illustrating the actual port interfaces. You know what I'm saying? On Cisco Model Lab, it doesn't actually do that. And that's why, again, there's a lot to like about GNS3. So let's just go back to open up our console now. Let me fix that one up because I have that one loaded up right here. But we need you up. We need you up. You. All right. That right here, so you guys can kind of see him. Just move you out of the way. Everybody can see what's going on here. All right. Cool. Hope that looks good. Let's go back to, so we got our switch here. Let's go back to PC1. I believe, yeah, this is the 10.0.0.1 1 2.5.2.5.2.5.0. All right, how do you want me to do this then? Crazy. Okay, so IP add 0.0.1/24. Config then. Doesn't have IP config. Show. So now remember, like I said, guys, the it's a pretty funky Linux image here. So let me just run that again. Question mark. Let's see what. Let's look at IP. Let's go IP question mark then. Let's do IP address 0.1 2.5.2.5.2.5.0 like that. That's easy. All right, cool. That's up. PC2. PC3. PC4. Let's go over here. Now, it probably already learned all the addresses. All right. But remember, we haven't, all we did was is we booted up GNS3. We threw a couple of PCs in there. We added two switches. All right. We haven't configured nothing in the switches yet. Let's do show Mac address. Come on, GNS3, don't get funky at me. All right, so as you can already tell, we haven't even pinged anything or anything like that. But this gives us a great example of what the chapter was covering. Okay. All right, so we'll take a look at these MAC addresses too. So it's saying on, now this might confuse you now. It's a little bit wrong on GNS3. I'm surprised they haven't fixed that yet. But I should bring that up to them. So on Gigabit Ethernet 0-1, which is this one right here, guys, okay? It is stating that a MAC address of 0.555, whatever, we'll go with the last 6801. Let's write that on there. So it's stating that 68, that's residing there, and it's saying that PC2 out of Gigabit that, so that's stating that 6801 is residing there. Now, again, what it is illustrating out of this port, it's Gigabit 0-0 port. It's stating that it has a couple of MAC addresses residing on that port. All right, so it's stating it has 3 actual MAC addresses residing off of this one port. Okay, so let's go back, get my thing again. I'm gonna go back to PC1. We're gonna verify. Just look again. We're gonna do show Mac, maybe. Will that show us? Let's just do show IP real quick just to see. All right. So that's gonna show us our Mac too. So here's our Mac. So Mac right here, Mac address. And we're going to look at the last 4. 6800. Oh, man, I erased it, didn't I? You clumsy guy. All right. So there's our Mac, okay? Now let me just use the eraser so I don't erase everything now. Let's go over to PC2. Let's do show IP again on this one. There we go. 6801. Cool. Alright. I gotta program these hotkeys so I don't have to do this. Go to PC3 now. And show IP. Cool. 6802. Same thing, 6803. Cool. All right. So we've established all of our MAC addresses. Okay. There's that. All right. So we've established all of that. Now we'll go back over to. All right. So that's this switch right here. Let's finish booting that up. All right, and here again, so we have 6801 out of its gigabit Ethernet 0-1. So again, 0-1, 0-1, 6800, 6800, gigabit 0-2, gigabit 0-2, 6801, 6801, and then again, remember, out of its gigabit 0-0, it's residing these. Now let's go over to the other one. Fix that real quick. All right, again, here we go. So 6801 is residing out of this gigabit ether, gigabit 0-0. All right, port 0-6801. Again, it's out of this one. All right, and again, here's 8877, which is this MAC address of this catalyst switch right here. All right, but now it's saying 6802, 6802 out of 0-1. All right, now again, don't get hung up because of the GNS3 is messed up right there, so don't get hung up on that. Again, 6803 out of this one. So without us configuring anything within this network, the switches themselves have already learned the MAC addresses of the devices, the end user devices, in our topology here. Now let's go back over to PC1, right? And hopefully we should be able to ping somebody, right? All right, so we're pinging PC2, which is residing, which IP address is 10.0.0.2, all right? And then we'll ping PC4. Again, we haven't configured anything yet, and it's already, like it mentions in the chapter, you can buy a switch, dump it right into your topology, hook up the interfaces to where you want it to do, to the interfaces of your end user devices, and by default, that switch is already going to work. STP is already going to be enabled by default. So again, if we were to add a third switch here, STP is going to block. It's going to block that. Let's get that fired up now. Let that do its thing for a second, and then we'll hook that up, and then we'll run some STP. We'll run a show STP, and then we'll see. I'm going to show you. Well, we'll see which one of these switches became the root switch. All right. Now, let me go back to the switch here. All right. Show. What happened? Oh, I know what happened. It's having a hard time because I added this other switch in it, so it's bogging down. It's bogging down hardcore the CPU. Yeah. I don't know if that was a good idea. It froze it all. That's what I get for adding too much and not giving it enough. So that kind of just shows you when you're using these VMs and whatnot, unless you're giving it the proper resources, it'll bog down pretty hardcore, pretty fast too. Let me just see what's going on. Oh, it froze completely. Close it out real quick. I might have to shut that off. me kill that. We might not be able to do that right now. Back. Come back. This one came back. That one came back. Cool. I don't want it to. It's doing this thing. Oof. I bogged it down hardcore. But just adding that one switch, it pretty much said, I'm stopping now. Goes to show you how heavy this stuff is. So, yeah, so we went over just the very high level of Ethernet LAN switches, layer 2 switches, okay? We haven't gone into layer 3 yet. All right, we're gonna get into that. Also, we'll get, once I'll go back and you know, or we'll just jump back onto CML, because I got CML configured pretty. I got that thing. I give that thing a lot of resources to run the way it does. So maybe tomorrow we'll be back on CML, and we'll run a similar topology using three catalyst Cisco catalyst switches. These images are layer 3, but we can still use them as a layer 2. But we'll demonstrate STP. We'll see what STP is actually doing. We'll see the root cost and all that stuff. So again, let me just check. I'm gonna just check YouTube real quick, because I know I got my YouTubers out there checking me out on YouTube. I just want to show them some love by making sure that if they have any questions in the chat, I'm gonna do any questions at all, guys. This is the time to ask questions. And yeah. So again, what we've covered, we've just give a quick overview. Let me just make sure. It doesn't look like I got nothing over in the YouTube chat. Let me swing back over to Twitch. See if I got anything coming up on Twitch chat. Doesn't look like I got anything on Twitch chat right now. All right. So again, guys, this has been a great stream. Tomorrow, let's give us a little breakdown on what tomorrow is going to bring us. Let's go over to chapter 6 real quick. All right. So tomorrow is chapter 6, configuring basic switch management. This chapter will cover the following exam topics: configure and verify IPv4 addressing and subnetting. Ooh, we're getting into subnetting. Subnetting. Ooh, that's gonna be fun. All right, configure and verify DHCP client and relay. Configure network devices from a remote access using SSH. So we actually might have to use. We'll be using GNS3. So we can configure SSH, because the ISOs that I have, the image ISO that I have on CML, that's the one that has the missing command on the IOSV, the router there. So we can't configure SSH on CML's ISO image for the router. But the older image that I have for the router will boot up on GNS3 here, and we'll be able to configure SSH from there. And then we have configure devices, control using local password. So we have some more in-depth configurations coming up here, guys. Some neat stuff, some SSH. SSH obviously is what you want to have enabled while you're communicating with your network devices. So guys, this has been a great stream. I appreciate all you guys joining me tonight. This has been super fun. Join me again tomorrow, 5 p.m. Eastern Standard Time. We'll be going over Chapter 6 of the CCNA 200-301 exam topics. All right. From my house to yours, guys, I love you all, and you guys have a great night. Stay safe out there too, guys. All right, and we'll be seeing you soon.